Well, good morning, everyone. I hope you've had a pleasant day so far. Looking forward to covering a few different things in our time together today. I want to jump in to looking at some things you've been reading at in your textbook, and then after that, I'll open the floor for any questions you might have, and then ultimately we will return to our discussion that we were just beginning to talk about in regards to internal tables. So hopefully you have been keeping up with your reading this semester. There are a lot of things that are referenced in your textbook that run parallel to things that we have been talking about, and some things that might be useful for you in the future in terms of things to factor into your assignments. But the most recent chapter that you were assigned to read was chapter number 6. And I want to take a moment and just walk through some of the things that are a part of that presentation and highlight some things that actually have a relationship to our last programming assignment. Chapter 6 talks about user interaction. And you'll notice that there's a section here that talks about the parameter statement and discusses the fact that when you include a parameter statement in a program, what you're actually doing is you are creating what is called the selection screen. And later on in the semester, we may come back to this and introduce more elements to a selection screen. You'll notice in your book here on the right side of the page that I'm showing you, there's an example of an ABAP interface screen that presents a lot of different fields and things of that sort for user input. That's an example of a selection screen. And so it talks about the parameter statement, which we have discussed, so that's something that should be very familiar to you. But then it goes on to talk about other things that can be incorporated into the selection screen that might be useful for us. And so one of the things I wanted to touch on here just very briefly is this idea of a radio button group, because that's something that we might want to incorporate into programs that we would write in the future. And so let me call up a sample program that I started that employs radio buttons. It's actually fairly straightforward as to how we can incorporate this into our program. The idea behind a radio button group is what you see here. The idea is that you can create a set of fields that are going to, as we'll see here in a moment, like the parameter statement normally, present text to the user. But what is different about this is instead of it giving a field that the user can type things into, we are designating this as a radio button group. And if you're familiar with the concept of a radio button group, the user is presented with a set of choices, normally with a little like bullseye type display next to it, and the user can only pick one of those choices. One of the things that is a facet of radio buttons in ABAP is there will always be one of the choices selected by default. So there is no way to have a null selection. There's going to be one choice selected by default, and the user can leave that or switch to one of the other choices. The coding for this is fairly straightforward. You give each of the choices a name, following the standard naming convention for parameter statement, and then you give the group a name. And the name of the group can only be 3 characters long. So it's very, very common just to use RB and then a number. So you could stick with that naming convention and on your screen have up to 9 different radio button groups. The idea here is that whatever is in the same radio button group has the logic that you can only pick one of, in this case, those 4. I could create another radio button group that would have a different set of choices, and then you could pick one of the N choices that are there. So we just use the standard chain parameter statement, the name of the field, the designation, the keywords here, radio button group, and then we give the radio button group a name. So if I run this code, this is what the user, oh, that's interesting. Let me, that's because of something that I did in my testing. that I need to undo. Okay, well, you would normally see add, subtract, multiply, and divide next to those guys. The reason why you don't is because I have a text pool set up. I tell you what, let's do this real quick just so you can fully see this. Create a new program, ZN035, demo prog 2. Okay, and so I'm going to go back in and I'm going to copy this code to another program so we don't have to worry about what's going on in the text pool at this point. Okay, so now when I save and execute this, this is what we see. Add, subtract, multiply, and divide. Notice that by default the first choice is selected, but the user can clearly change that. Now, there's two more things for me to show you that are kind of hinted at, but not really explicitly mentioned in your textbook. One of the things that obviously we have to understand how to do here is how do I tell which one the user picked? And the logic here is really kind of a bit different. I can't think of any other programming language that works this way. The radio button that was selected will have the value of that button set to capital letter X. So the typical way we do this in our coding is this. We do a case statement based on capital letter X, and then I do when, and I give the name of the parameter. So when add. So now this is the scenario for when the user has chosen the add radio button. And for the sake of this demo, I'm just going to have it write out to the screen addition. Okay, when subtract, going to have it write out to the screen subtraction. When multiply, write multiplication. And lastly, when divide, write division. All right, so assuming I have not made a typo, if we look at this now, and it does look like I made a typo. Oh, so, all right, so if I choose subtract now, you'll notice that nothing appears. Oh, so why am I not getting anything to appear? Oh, this is an odd thing that let's check and make sure that they're all broken. Oh, I double-clicked. Can't do that. I'm sure all of you laughing understand the joy of that. At least it didn't launch another element into the ABAP dictionary. Multiply when DI. All right, let's try this again. Okay, now I am officially puzzled. Case X when.
Say when X is equal to one of the choices, or one of the choices equal to X?
No, the logic is when the value of the choice is equal to X, but the syntax here is as it should be. I have made a typo somewhere, apparently, that I am not spotting. Oh. I'm Sorry. I'm trying to match up this. This says match up the literal string add, but it shouldn't be. It should be match the variable add. So I apologize for that. So please do fix that on your note sheet there. I knew something looked awry, but I couldn't figure out what that. Yeah. So what I'm doing here now is I am looking to see when the variable, in this case, add, subtract, multiply, or divide, is equal to the value of x. So in relation to the question was this, I could use an if statement for this and test to say if add equals capital letter X, but the case statement gives me a clear logic to go with it, and you can see now it does work for multiplication, addition, whatever have you. Now this, of course, would not have matched the spec that I gave you for the last assignment, but in future assignments, this is something that we could incorporate into the solution. What's one of the merits of this approach? Controls the input, so what does that mean in terms of the program I write?
Less validation. It's kind of a validation for you.
I know I'm going to get one of the choices, right? So what is not present in my code that, for example, should have been present in the homework code that you wrote related to this? I don't need a when others clause because there's no way for there to be anything other than those four choices. So it eliminates the when others option. Now, suppose I wanted the program to work as we see here, but I want to change the way things are actually presented to the user. I wanted to make it match up with, for example, the spec of your homework assignment where it used the symbols instead of the text. No problem with that at all. What I am going to have to do first, though, is activate the program because I'm going to go into the text pool and set the selection text. So just like other parameter statements, I have the ability to control the selection text, so I could put the various symbols here for the options. And then anytime I set a selection text, I have to activate the selection text. So let me do that. And now I can go back to my program, and when I run it, we'll notice the user has the choice of the operator there instead of the text. And so they could pick the symbol and then execute, and you see it still does pick it up as being the correct choice there. So you will notice that with the highlighting here, you might see that little red box that's around the item. That is sometimes used for kind of highlighting the region of the screen that is selected. It doesn't have much meaning to us other than creating a visual artifact, but I can tell you based on my experience with a student I had previously in this class that if you are using screen reading software, for example, if the user were vision impaired, that would actually read as / and then it would read the word division out to the user in this instance. So there are other things that are presented in Chapter 6. Any questions about this, though, before we turn our attention back here? So you'll notice there's check boxes. Yes, sir.
It involves multiple radio button groups. A couple questions. So
Okay.
first, in the parameter statement, can you just keep going and do like if you want a second radio button group, just do comma and then something radio button group RB2?
Oh, absolutely.
Okay.
You know, I could do test, radio button group, RB2, test 2. Oh, forgot the comma. Radio button group, RB2. And I won't put in the logic here associated with it, but I now have 2 radio button groups. They're kind of butted right up against one another in this situation. I do think there was some discussion in your chapter reading about how you can do things like put things in boxes or things of that sort that we won't talk about that could allow you to tune the visual presentation. But absolutely that would work.
You'll set that second radio button group, the division stick, that'll also be text.
It's all based on the name of the variables that are used. So really the only time the RB1, RB2, the radio button group name is used, is for the sake of telling the system that this is a different radio button group than the other. It in no other way gets incorporated into the logic of our program. So we could do another case X and do when test and when test 2 as the cases there. Now you could, it seems to me like it would be a logical problem, but you could embed when test and when test 2 into this logic right here, but you would never hit it because the user would have picked one of the 4 choices and that logic would have been fired, and so the other code there would be unreachable. Okay? Other questions? Yes, ma'am.
To get to the text editor where you can change it, all you have to do is activate it. Because I feel like I tried that and I ended up installing it as a transaction to get it to work.
Shouldn't have to. The two-step process, the multiple, you save your program, you activate your program, you go to text elements, selection text, and then once you save this, you have to activate this too. So that might have been something that got missed, and maybe when you activated the transaction code, it presented a list of things, and you activated all of them. So that could have been why you had that experience. Okay? Good questions. Other questions? All right, so there are, let me just real quickly here finish flipping through some things, and we will do some things with some of these more advanced field options here. Notice here, this is what I was talking about, where you can put a blank line, you can create a horizontal line, you can put various parameters and such in a box to create a little bit nicer visual display. Notice this one right here, you have a heading and then you have some fields and then you have another heading and you have some fields. So we can add those kinds of refinements, and you certainly are invited to do that in your programs in the future where it might be appropriate. And we'll talk more about messages when we start doing some things with database work, because it becomes very important to us. And I mentioned this earlier in the semester, but we didn't really show you an example of it. The fact that ABAP is multilingual, so you can actually create translations for programs. And notice it tells you if you want to do that, do go to translation. Let's look at that real quick, because we could actually do that with our program here. We could do go to translation, and we're going to translate from English to, I don't speak any of these, so we'll pick German, okay? And so now what's going to happen is, after a second here, this is the first time we've, all right, so what's going to happen is the user, remember the selection text was the word add, divide, multiply, and subtract. This is, I don't do this for real ever, so, but just to show you this, the idea is that we could type in what would be the German equivalent of the word add, which I have no idea what it is, so I'm just going to assume it's add it up, okay? And then the German for divide is divide me, okay? And multiply German, okay? So the idea here, and the way this would actually, subtracting, okay? The way this would work is a company would typically hire someone or multiple people to do translations. And then at this point, the process, you see all these buttons over here? Right now, these are suggested translations. But what you would actually do is you would have someone other than the translator look at this and say, yeah, that looks good to me. And you would be able to allow people to vote on whether a translation was good or not. And that would result in this being turned from yellow to green, because it would no longer be a proposal. It would be a validated translation. But then we can't really show you the results of this, because what we would have to do is I would have to log into the system, and on the login screen, I would have to tell it I want to log in German. And if I did that and ran this program, I would get the German translations. The problem with that is, as soon as I log in German, the whole interface turns to German. And I can't find things in there other than just remembering what the transaction codes are. But if any of you do happen to speak another language, one of the 4 that's supported, you could log in that other language, and then you could use this to kind of see how that works. So your book talks about it. It is very, very useful for global companies that have to support users in other languages, but obviously it's beyond the scope of our class to really do anything actually meaningful with it. So chapter 6 in your book is where you should be read up to at this point, and so I just wanted to hit the highlights of some of the things from that presentation. In our time together today, we are getting ready to jump back into where we left off last time, which was getting ready to talk about internal tables. But before we head there, I do want to pause for a moment and see if there are questions about anything. Yes, sir.
When we were on the homework, I was trying, and I said this has something to do with the parameters, content selection screen, but I was trying to put it in a loop to catch any errors and have it recall the parameters, and it wouldn't do that. It would just bypass it when I was running through the debugger. Why is that?
There, we will learn later, and I don't know where it shows up in your textbook, but you can do selection screen validation, but there's a set of syntax associated with that we have not yet covered. So really, your only choice at this point is you can, for example, if you tell the parameter statement that the user has to put in an I, you'll get automatic checking that we've seen before that won't let the user put a decimal in or an alphabetic character. But anything more sophisticated than that is going to require us to do selection screen validation, which we will get to. But right now, what you pretty much have to do is once the user hits the execute button, that's going to cause the main logic of your program to execute, and at that point you just have to be prepared to handle all of the valid things that could come to you. The nice thing is we have talked about the obligatory clause, which saves us from having to write a lot of logic for what if the user didn't give me values. So that really cuts down on that as something that we have to test for. Other questions?
Do you have any specific naming conditions, like as far as naming your variables?
No, what I like to see is good variable names. For example, the second program that you wrote where you were building that multiplication type table, I think that probably code would have been a lot easier for people if they had thought in terms of maybe making variable names like row and column, so that you could say, oh, well, you know, to get this answer, I multiply row times column, and logically that makes sense. But I like to see variable names that have some kind of semantic meaning to them. But beyond that, we may a little later in the semester, once we cover more, show you some of the naming conventions that are sometimes used in companies for designating internal tables and things like that. But it's fairly, there's nothing as evolved in ABAP as, like, for example, Hungarian notation is in other programming languages. Other questions? All right, well, internal tables. I'm excited for us to get to this topic because it certainly will enable us now to start doing some much more interesting things in our programming. Let me just real quick review. The idea behind an internal table is, in other programming languages, we have arrays. We don't have arrays in ABAP, but what we have is this idea of an internal table, which has a lot of similarities to the idea of an array, but also carries with it some very nice things, such as it's a dynamic data structure, so I don't have to worry about saying that I want an array of size 100 and being afraid that I'm going to have to actually go beyond that. I don't need things like linked lists because the system will automatically grow and shrink my internal table accordingly. So once we get used to using internal tables, you will see that they really do make our code a lot easier, particularly when we're doing things like database interaction. And we left off last time with the concept that there are three different kinds of internal tables. There's a standard internal table, a sorted internal table, and a hashed internal table. The key here is, no pun intended, that with a sorted table, we will always designate one or more key fields, and the table will be sorted by those key fields. Now, I'll point out that we do not have control over the logic of the sort, meaning it's not like Excel where you could say sort this in normal alphabetic order or sort it in reverse alphabetic order. It will always sort it in, quote, normal alphabetic order. So I have a sorted table where, for example, if I have records in it of people's information and I want it to be sorted by their last name and then their first name, sorted table is a great structure for me to use. A standard table is a table with no inherent order. So unlike the sorted table, which keeps things in alphabetic order, the standard table is essentially in random order based on the information that's loaded into it. And then we have the much more specialized kind of internal table, which is the hashed table, which requires me to have keys, requires those keys to be unique, and this is very valuable for when I want to create some kind of internal table that supports unique keys and I want to have linear search time. So from a big O perspective, of these, the one that is the much more efficient to search for and access would be a hash table, but the scenarios in which I can use a hash table are much more limited. So let's turn our attention today to the actual syntax of this. So I want to create an internal table. The first thing I have to do is create a type definition for my internal table. So you'll notice I begin with the keyword types, and then I give a name to my table type. So this might be address table type, or person table type, or whatever it is that this particular table is going to be based on. And then you'll notice now I have to tell more about this table I'm creating. Keyword type, and then table type. Now what's table type? That's going to be one of three things. That's going to be standard, sorted, or hashed. So it will say type, for example, standard, table of, and now I have to give what is the data type that makes up this table. So if we use the handout that I gave you earlier, and let me find my copy of the handout here. I might have given all of my copies away. What was the name of the type that, oh, I have it right here. On your handout, you'll notice I defined a person struct type. So we might say type, standard, table of, person struct type. So now I'm going to have a table capable of holding these structures. And then the last thing I have to do is account for what my key situation is. With, and then I have two choices, unique key or non-unique key, and then I list the key fields. So hypothetically, if we use the handout I gave you as an example, we might see code that would say types, person struct table type, type standard, table of, person struct type, with non-unique key last name. Okay? So all I have done here is match up the type that's already defined, the structure type, with the elements of the internal table I want to create. Yes, sir? I have this one right here, so I guess you get that. All right, other questions? Now, technically, the type here, meaning this data type here, could be any data type. So I could do this. I could do types, integer table type, type standard table of I, with non-unique key, and then I wouldn't really have any key fields at all. And at that point now, I would have a table that would be capable of storing integers. Don't know that we'll ever actually use that. Don't know that it's commonly used at all. But as a point of fact, the data type here could be any number of different things. But the vast majority of times, it's going to be a reference to a structure type that we would have defined. Now, if I don't have to have a key, and if I don't want a key, I could just leave off any reference to the key. So I could leave off with unique or non-unique key and listing. I could just put the period right here, and I could say types, person struct table type, type standard, table of person struct type, and just stop at that point. Now let me ask you this. What does that tell me about the table that I am creating if I elect not to define a key? It has to be a standard table, right? Why? Okay, and if you think about the logic here, I can't have a sorted table that doesn't define a key, because the sorted table is sorted based on the key. So I can't do that with a sorted table. And with a hashed table, the only way I can access the information is by specifying the key. So with both the sorted and hash table, I have to put a key in. So basically, you could write next to this, if I want a standard table and I don't want a key, then I can just leave out the with key. But remember, what we said about this is, with the standard table, there's no inherent order to the rows. I can access the table by row number and by key values. Well, if I don't specify a key, now all I can do is access the table by row number sequentially. But there's plenty of times when that matches up with what it is that I want to do. So the idea here is that the with key clause can be deleted if I want to create a standard table and I don't want it to be searchable based on keys. If I have multiple keys, so for example, if we wanted to use the data structure that's on your handout, and I wanted it to be, let's say, a sorted table, and I wanted it to be sorted by last name, then by first name, I would put last name space first name in the key portion of the clause. The key element there is there's no comma. It's just a space that separates the field names. A standard table can have only non-unique keys. So we'll see, if we were to try to create a standard table and said with unique key, that would be flagged as a syntax error. So even if, based on your knowledge of the data, you know that the key is unique, that's fine, but ABAP is not going to enforce that, and so ABAP will not allow you to say, oh, it's a standard table with a unique key. A standard table can only have non-unique keys, hash tables can only have unique keys, and sorted tables can actually have either. So you could have unique key, you could have a sorted table based on unique keys, you could have a sorted table based on non-unique keys. So for example, the table that we could create based on the handout that I gave you, we could have multiple Robert Johnsons. No problem with that. And in fact, if this is a customer table and we want to sort it by username in that fashion, that would not be that unusual. Now, it might be that in our database, those Robert Johnsons all have unique customer ID numbers, but if I'm just printing out mailing labels, I didn't even grab that information from the database, so it's not even something I'm going to build into my internal table. So let's look at some examples here. So standard table, no key. And this is once again based on the handout that I gave you. So types, standard person table type, type standard table of person struct type. Seems a bit verbose there because of how long my type names are, but certainly makes it clear, and I think really not much in the way of tricky syntax there. If I want a standard table with a key, standard person table type, type standard table of person struct type with non-unique key last name. And once again, like we observed a moment ago, I don't know why my pen does that. It writes in a different place than I actually point it. But nonetheless here, the idea is the standard table has to have non-unique keys. I could not change that to with unique key last name. Now, what's the difference in what I can do in my code now between these two types? What can I do with the bottom one that I can't do with the top one? I could say, give me the set of records where last name equals Smith. And on this bottom guy, that will work. And I'll show you the syntax for that later. But logically, I can say, go into the table and pull out all the people with last name Smith. With this top one, I can't do that because I did not designate a key field. Similarly, on the bottom one, if I wanted to be able to pull people out based on their last name and their first name, well, I would just do with non-unique key last name space first name. And then I could say, go into the table and find someone with the last name Johnson, first name Robert. And it'd go in and find all of the people that match. Notice in both of those instances, I said the people because it's a non-unique key. I may get multiple matches back. For example, if I did say, give me all of the customers with the last name Smith, and I'm a large company with 10 million customers, it's probably going to retrieve more than one Smith in that instance. Now, it's important to realize that what I have shown you here are type definitions. So in order to actually make one of these internal tables, I have to pair it with the data statement. So this is what that data statement would look like. Data, my addresses, type standard person table type. So what you will commonly see in programs is a type statement that defines a structure. Then you will see another types statement that defines a table based on that structure. And then you will see a data statement that makes the actual internal table. So it's kind of a three-step process. On the handout that I have given you, I did step one, which is I created the definition of the person struct type. But we haven't yet actually written code to go along with the other options. Questions? Well, let me just show you a few other variations, and then we'll start playing around with some code here. A sorted table, and let's just say I want it to be a non-unique key. So I could have multiple Robert Johnsons in my table. Type sorted person table type, type sorted table of person struct type with non-unique key last name. And once again, if I wanted it sorted by last name, then by first name, I would just add last name space first name to designate multiple keys in that instance. If I have a unique key, the syntax here is almost identical. The only distinction is I say with unique key instead of with non-unique key. And in this instance now, when this table is filled or when this table is manipulated in my program, it will enforce the fact that the key field first name, or excuse me, in this case, last name and first name, that key field combination has to be unique. So I could have Johnson Robert, I could have Johnson Phil, I could have Johnson Bob, but I couldn't have multiples of those things. The key has to be unique. Questions? So just to be clear, what's actually going on here in all of this code that I have written is I have created an empty internal table that in this instance is capable, I'm just going to abbreviate, of holding a last name, a first name, and a, what's the other field here, a title, okay? So I have an empty table that is either sorted or not sorted based on which example we're looking at. So I want to work with this guy. Well, in almost every program where I create an internal table, I have to create something to go with the internal table. And that something that I have to create is called a work area. When creating an internal table, it is very That should say it is very common to also create a single data object, a structure that matches the lines in the internal table. This data object is typically called a work area, okay? So here's the idea. I created this internal table that I've drawn on the whiteboard, and it is, if you will, it is a three-dimensional object in that it is capable of holding multiple customer information. A work area mimics this structure, but contains only one line, contains only one record, if you will. Okay? So I would have last name, first name, and title. Now we'll get to the specifics of this, but the idea would be something like this. I would fill up the work area with information, and I would say, okay, last name Smith, first name Tom, title Mr., and I would build that work area, and then I would add it to the internal table. So the work area kind of gives me a tool for filling the internal table or pulling things out of the internal table, but that's why I say it is very, very common in programs to create an internal table and then create a single-dimensional structure that matches that, which we call by convention a work area. It is worth noting that if you look at a really, really, really old ABAP program, there used to be something called a header line. Header lines are deprecated. Header lines were replaced by the concept of a work area. So if you ever actually see in the ABAP documentation reference to header lines, or you're maybe looking at code online that it talks about header lines, just don't even see that, because that is something that is extremely deprecated and in fact will break things that we will do later down the line. Okay, so work areas are what we use, header lines are deprecated, they do not work with object-oriented ABAP, and there are a lot of other reasons why they have been abandoned. So I note them here simply to admonish you not to be confused by them should you encounter them in the future. Questions? Okay, well, let me introduce you to something that we will use a lot this semester, which is we will do a lot of database-related work with SAP. For reasons that you can probably understand, we need to be very, very careful about how we go accessing and using various database tables in the system, because we could make a mess of things. We also have a system that, although it has everything we need for ABAP development in it, doesn't actually have live customer data and other things of that sort. So SAP provides in the system the ability to create a set of training database tables based on airplanes and airports and flights and things of that sort. And so we're going to make use of that a lot in programs that we write this semester and in demos we'll do in class and things of that sort. Now there are a whole set of tables, but these are just some. For example, there's a table out there called S Airport, which has information about airports. There's a table called S-Car, which contains information about airlines, SP-Fly, flight schedules, S-Book, flight bookings by customers, S-Custom, flight customers. Notice transaction SE16. Let's take a look at that real quick. SE16 is a transaction that you might find occasion to use a lot this semester. If I run that transaction, I have what's called the data browser, and this is for database tables. So for example, I mentioned there's a table out there called S Airport, okay? So if I want to know more about this S Airport table, I can type this in for any old SAP table, and notice the buttons I have here at the top: table contents, create entries, user parameters, and then online manual. Don't need online manual. So notice if I type in Sport and just hit enter, it says, okay, what do you want to look at? And the idea here is if I leave everything blank, it's going to show me everything that's in the table up to a maximum of 200 records. So if I, for example, hit this number of entry button, I can see there's only 53 airports in this whole table. So if I leave this totally in default, leave everything blank and hit execute here, it's now going to show me what's in this table. There's a field here called Mont, which should look familiar to you. That's our client number. There's a field called ID, which if you've flown before should look familiar to you. That's the 3-letter abbreviation that's standardized for airports. The name is where the airport is located, and the time zone is the universal time code time zone that that particular airport is in. You will notice that Tri-Cities Regional Airport did not make the table. But at some point this semester, we will add that, okay, as one of our exercises. So this is a database table, and the good thing about this table is if we mess this up, which we don't want to do, but if we mess this up, we're not going to undermine the integrity of the SAP system, because this table exists just solely for the sake of our practicing. If I go back here, and for S Airport, I didn't necessarily want to look at the contents. If I just wanted to know about the structure of the table, this really isn't the best query for me to use for that. And so I'll show you that in a later discussion. But let's look at a couple other ones here. S Custom, we had said, was information about flight customers. And so if I do that, notice all the different, this kind of gives you a hint as to what the fields are. And it's always good to check the number of entries. I can see there are actually 4,637 people in this table, but when I execute this by default, it's only going to pull out the 200 of them, so as not to bog down the system, because you could browse a table this way that has millions of records in it, and you wouldn't want to pull all of that out if you just wanted to get a sense of what's in the table. So here's a table. We have the Mont field, we have an ID number, we have the name of the customer, which you'll notice is actually the name of a business. Form, this is the form of address, and you'll notice that a lot of these customers seem to be German, because we have Air, but we do have Miss and Mr. We have companies, but you can see you get into some of these German titles like Air, Prof, Doctor. You can see a street address, a post office box, postcode, that would be what we'd call a zip code, city, country, if I scroll over to the right. Now, you do have to be aware that if there are a lot of fields in this table, it's going to limit how many I'm actually looking at here. But let me back up. Notice all the customers, are in different countries. So if I went back to this screen right here, and I said, just give me the customers that are in the country United States. So I could use F4 help. Oh, I thought I could use F4. It's not going to let me do that. So I just happen to know that EN is the country designated here. And so now, well, I thought it was showing that. Let me go back and look at my table again. Country. I see a country. I thought I saw EN. What's it using for? Is it using US? Using US. That's right. EN is for English. That's not a. That would be England, which aren't England customers in here, but US. Okay. Now it's pulling out just the US customers. So essentially, from a database perspective, this screen gives me the ability to specify where clauses. And I could say either give me a single value, or if it's something alphabetic or numeric, I could say give me from this value to this other value. Or if I wanted to specify multiples, for example, if I wanted the US and Germany, and so Germany you'll notice is DE, and then CH, which I'm going to guess is China, but I'm not, Zurich's not in China. So, but anyhow, you see the country abbreviations here. If you said I want 3 of them, that's what this button over here is for. So I could do country, multiple selection, and then I could say, okay, give me US, give me DE, and give me CH. And now, notice it doesn't change this, except if you look real closely, it put a green kind of arrow in this one to show that multiple selection is active. And now it's pulling out just those customers that match those choices. Okay, so this table browser can be a very useful tool. Yes, sir?
Since you can search by all of that, does that mean all the fields are unique?
This is a program that SAP wrote, so it is not necessary, and there's no internal table here. This is a database table. Okay, all right. So, and so that's kind of a good transition to my next thought here. In most programs where we're going to access database tables, we will use internal tables. Okay, so the idea here would be, if I wanted to work with one of the tables we just looked at in the database, I would create an internal table that would contain the fields that I want to, let's say, pull out of that database table. So the common strategy here would be things like I could fill an internal table with desired data, maybe pulling it out of the database. I could use the internal table as desired. I could dump output to the screen. I could use it as the basis of some kind of report. I could update the data in the internal table. And then, hypothetically, I could update the database table as desired based on internal table values. So let's say, for example, that Johnson City changes its area code for telephone numbers. And we're no longer going to be 423, we're going to be 424. So we want to go in and we want to update all of our customer records that show Johnson City as their home city. And it probably would be a good idea to check to make sure that 423 is their currently defined area code. Well, the way that I would commonly approach that would be to go to the database and pull out all of those customers into an internal table, update the internal table, and then use the internal table as the basis of an update for the database table. Now, why would I do that instead of just manipulating the database table itself directly? Okay, I like that idea. I like that word, quarantining the data. So why would that be valuable? Okay, that's great that was the first answer, because that's really perhaps the best answer to this. I have to make sure my program doesn't screw anything up. So it is very, very common for me to want to not manipulate the database table until I'm sure that I have done exactly the right thing. So I will pull data out of the database table into the internal table. I will write code that will manipulate what's in the internal table, hopefully building logic into my program to enable me to test it out to make sure that I've manipulated it correctly. And then when I'm done with that, then I'll use it to update the database table. So it gives me a way of pulling data out, working with it in my program in a quarantine type situation, and then sending it back as appropriate. So one of the things that it gives me is a way to protect, if you will, the integrity of my data. What's another reason we might follow this structure that I have described.
Load balancing.
Okay, tell me more about that.
Well, instead of interacting directly with the database and like having to make multiple queries and everything, you're just like making one query to pull what you want, manipulating it outside of the database and then throwing it back in.
Excellent. So the database, realize, if you will, is a very valued resource from a performance perspective. There are millions, potentially, of users worldwide hitting this database. So I have to be very, very careful not only about data integrity, but the performance of this database. And if I start going in and making a lot of changes, there's the potential here for me to disrupt the system or reduce system performance. Imagine, for example, if I had a customer database table with 75 million customers in it, and I wanted to run a program that would update the database table for all the people that live in Johnson City and change their area code. Well, how long is it going to take for the database to scan through those, however many, whatever number I said a moment ago, those tens of millions of customers to make those changes? And what other work is kind of going to be put on hold while it does that update? So it's much more efficient for me to say to the database, hey, give me back all these customers. That's going to be a really relatively simple select statement. I'm going to pull it into my internal table, do my manipulation, and then send the data back. Now, this is a good place for me to mention to you for the very first time something that I will probably say 10 million times before the semester is over. Select star is evil. Do not ever, 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 ever write a select star. Why do I say do not write a select star?
In the previous example, you had 4,000, over 4,000 rows, so you're selecting all that and tying up all of your performance.
Okay, but select star, you focused on the row aspect of that, which is good. What's the other thing that select star governs? The columns, okay? Now, we saw this a moment ago, that the table we just looked at for customers, I don't know, looked like it had about 15 fields in it. I don't know that we will cut into too many standard SAP database tables this semester, but it is not at all unusual to see SAP database tables with over 250 fields. A customer table, for example, it would not be unusual for a customer table to have dozens of fields in it. If all you want to do is update their phone number, you really don't need to know all of the other data that's contained in these 250 plus fields. So we want to get in the habit of only pulling those things out of the table that are needed for the work that we're doing. Okay, so to give you an example, and this is a program that I might ask you to write in the very near future, if you have a customer database table that has customer numbers and phone numbers and contact names and their mailing information and all kinds, you know, their fax number, all of that, and you wanted to write a program that printed an alphabetic list of just their mailing address for creating mailing labels, you don't need to pull their phone number out to create a mailing label. You don't need to pull out what time zone they're in to create a mailing label. So you would create an internal table that only contains the fields that you need, and then you would not write a select star. You would write a select, you know, company name, street address, city, state, zip, whatever. And I'll show you how to write that select statement in the future, but you've written select statements like that in your database class, and I don't know if your database teacher beat you over the head with this or not, but you do not ever want to write a select star statement. I work with some companies where I do some training for them, and this becomes kind of a running joke, where like if you were a developer working for a company and you wrote a select star, it's the kind of thing they like might take your picture of and put you on the bulletin board and said, this idiot actually wrote a select star statement, and everybody would give you a hard time about it, because you just do not do that. The performance hit associated with that is absolutely severe. Okay? Questions? Yes, sir.
Then that also, I mean, because when you bring in your data from your database, you're bringing that into active memory, so you're essentially eating up those resources as well, right?
Absolutely. Yeah, so we want to, the fact is we're going to be manipulating in a real world setting some pretty big chunks of data. So it would not be unusual for my program to go out there and maybe grab a few gigs of data. But I don't want to grab any more gigs than I need to get the job done. So by all means, grab what you need to. Don't say, well, I might need this field, I might not, so I'm not going to grab it. Don't do that. If you need it, you need it. Just don't grab anything ever that you don't actually need. And by the way, as an aside, later on this semester, we'll talk about column store databases, just as an aside, which SAP HANA is based on. In a column store database, select star will just absolutely eat your lunch. And so a lot of reasons why we don't want to do that. Now, we haven't gotten to the nitty-gritty of how to work with these internal tables, but I will say the syntax for working with internal tables and database tables is really, really similar. You've written in your database classes insert statements to put new data into a database table. We have an insert statement for internal tables. It's really, really similar, but there are some subtle differences. But just in general, the same concepts that you have for a database table, insert, update, delete, other things like that, we have with internal tables as well. But there will be times, and there'll be times I will do this semester, where I will, I'll mistake the syntax, and we'll have to, be careful about it, because we'll type one thing and think it's right when it's not right. Now, there are two choices, and I'm not sure, do you guys have this slide? For those who have the slide, do you have this? Okay. There are two choices when I want to create an internal table to match the structure of a database table. Okay, so here's a scenario. I have a database table that has 15 fields in it, and I want to create an internal table that has those same 15 fields in it. If the internal table will encompass all the fields of the database table, then you can specify the name of the database table as part of your internal table creation syntax, okay? So let's look at this. I could do data, itable, type, standard or other, table of, and then I list the database table name. Now you might notice this kind of resembles the syntax for a type statement where I'm creating an internal table. So in fact, even though I don't show this here, I could add to this clause with, if it's a standard table, with non-unique key, and I could list the key fields. So if you want an internal table that matches the structure of the database table, this guy can save you a lot of time. If the internal table will encompass only some of the database table fields, you're better off to define your own structure and base your internal table on that structure. Now, there's a trade-off here. Let's assume, hypothetically, that there's a database table with 18 fields. And you and your program need to manipulate 15 of those fields. And when I say manipulate, that doesn't necessarily mean change. It just means you need to work with 15 of those fields. Well, that doesn't mean I'm going to do a select star, because I don't want to pull in those 3 fields that I don't need. But from a data structure perspective, if I create an internal table that has 15 fields in it, that's going to require me to write a lot of code. I could say, give me an internal table that matches the structure of my database table, and then just not fill some of the fields with data. That's not the end of the world, because as we can see here, I'm using 15 of the 18 fields. But if my database table has 250 fields, and my program uses 4 of those fields, don't say, give me an internal table to match the database table. What I'm going to want to do is define my own structure that matches up with those 4 fields, and then I will create my own internal table that matches up with that. So how do I know? A moment ago, I showed you how to look at the contents of a database table using, what was the transaction code for that? SE16. But suppose I want to know what fields are in the database table. Well, I could avoid ever using SE16, and I could always go to SE11. Now, SE11 is my transaction code that gives me an interface into the ABAP dictionary. We will probably talk about the ABAP dictionary, if not when we get together on Thursday, then next week. You will notice that one of the things that is here in my choice of accessing the ABAP dictionary is this guy right here that says database table. So I could put in the name of a database table, S airport, and I could say display. And the first thing it's going to show me is the fields in this database table. Now let's understand what we're looking at here. We have a list of the names of the fields. There are 4 fields: Mont, ID, name, and time zone. Mont and ID are key fields. We can see that because the key is checked there. Initial value required is checked for all 4 of these. So there have to be values for that. Those can't be null. The data element, okay, this is fundamentally the data type of this field. And unfortunately, it's hard to tell, particularly on the projection here, but this is S underscore Mont, and S underscore airport, and S underscore airname, and S underscore T-zone. So in other words, the name of this field is ID, and the data type of it is S underscore airport. Then the other information over here is just to very quickly enable me to understand what I'm looking at. S airport is character data type, 3 characters long, obviously has no decimal places associated with because it's character data, and the semantics of that is that's the airport code. So this is a very, very useful presentation for wanting to find out the structure of what's in a database table. Well, let's look at, just as an example here, an actual SAP table, T001. T001 is the company code table. For those of you that have taken information systems implementation, you're familiar with the concept of a company code and what it really means in an organization. The table T001 is where we can see company code information. 81 fields, okay? You can see all of the different fields that are in this particular table. It includes the company code and the name of the company code, and the city that they're in and the country that they're in. Now notice there are buttons here at the top, of which I think it's this one right here. If I click on, will let me look at the contents of this table. So you'll notice now at this point, this looks like that other transaction I showed you where I could look at the number of entries. That's interesting. There are only 2 because this is not a real production system. And so when I execute this, I can see that there are only 2 companies in the system, Global Bike Germany and Global Bike Incorporated. One's based in Heidelberg, one's based in Dallas. One uses English, one uses German, one uses US dollars, the other uses euros. Don't know what this stands for. And now we get into the fun world of these are abbreviations based on the German language, okay? So K-Toppel, okay, what does that stand for? Notice I can double click on chart of accounts. Oh, okay. So once again, if you took the course where we focused on configuration, you can see these both use the same chart of accounts. WABWA, okay, what's that? Maximum exchange rate, deviation, and percent, okay? We're never going to write a program this semester where I ask you create a list of blah, blah, blah based on the maximum exchange rate, deviation, and percent. But you see here, this tells me there are 79 fields, but we're only showing you 27 of those fields. Notice as well another thing that is very, very common in SAP, a lot of empty fields. because you have these tables that basically have fields that are available if we need them, but if we don't need them, they just stay empty. So this is not at all that unusual. So let's pick another one of those practice tables. There was S Airport, there was S Custom, I think. Well, we looked at S Custom, we looked at S Airport, SP Fly, SP Fly. Display, be careful, you don't want to hit change here. Display. And here's the fields in this table. There are only 16 fields. Carrier ID, country key, departure city, departure airport, arrival city. And so if we look at the data here, we'll see in fact that there are 26 flights in this table. So not a huge amount of information. But this says there's a flight that goes from New York JFK Airport to San Francisco SFO Airport. And the flight time is 361 minutes. Here's the departure and arrival time. Here's the distance. I think the distance is, well, it doesn't say if that's in, oh, it does. There's a field here for whether the distance is in miles or kilometers. And so this is a way of finding out what fields are in a table. So I could look at this and say, if I actually write a program that prints a list of flights that are in the database and tell me where you can fly from and where you can fly to. Well, we know there are 16 fields, but I don't need to pull in the miles that separate them or the flight type or other things like that. I just need departure city and arrival city. Well, I wouldn't want to say, give me an internal table that matches up with this whole thing. I would want to say, give me an internal table that has those two fields. So how do I do this? I'm going to have to create a structure, and I want the fields of my structure to match up with the data types of the fields in the database table. So I have a couple choices here, but one of the things I could do is I could look at this, and a lot of times I'll grab a screen capture of this or something like this to use as a reference, and I would say, for example, I need a structure that has a field called city from, and the data type of that field is S_from_sit. And then I need another field called city2, where the data type of that field is S_to_city. And I make my structure match the data types of the database table. That gives me data integrity. It allows me to make sure that when I pull data into my program, there's no type conversion, there's nothing that's going to happen that will later cause that data to deviate from the way that it's defined in the ultimate database. So, questions about that? Let's go back to some of the things we talked about. There are a couple of different ways that I can create a work area. But one way that I like to create a work area is by using the line of code data, and I give my work area name, and I will almost always call my work area WA. Data WA like line of iTable. Now I said there's two different ways to do this. If we think about that for a second, we should very easily understand why that is. In my sample program that I gave you on hard copy, I defined a person struct type. And then we used it in our discussion to create this internal table here on the whiteboard. So if I wanted to create a work area that matched the structure of this internal table, would you not agree with me that one way I could do that would be just to create what you see on line 7 of your program? That's creating a structure called sample person that matches up with the structure. But just to make my code a little bit clearer, I can say, give me a structure that's like a line of the table. If I want to fill, and this will be the last thing we do here, fill an internal table with data from a database table, I can perform an operation called an array fetch. And I'm about to show you code that I told you a few minutes ago you should never write. Select star from DB table into table iTable. Now, select star is bad. So what that really should be, and a better example, would be select and then the names of the fields separated by spaces. But if you have a one-to-one correspondence and you truly are retrieving all of the data in the table, then I will permit you to use select star in that very, very limited case. Okay? So next time when we get together, we will play around more with internal tables and finish that up and then start talking about more things in the ABAP dictionary. Have a great rest of the day, everyone. If you didn't get a chance to sign in, please make sure you do that before you head.